minus omega t plus delta. Tell me, what will you get if you subtract this quantity from this? Let me write that down for you. That will be A minus B will be kx minus omega t minus kx minus omega t plus delta. That will be kx minus omega t minus kx plus omega t minus delta. And if you notice here, kx minus kx will go, negative omega t plus omega t will go. You will be left with a negative delta. So this will be 2a cos A minus B becomes delta, negative delta. So that will be cos of negative delta over 2. Alright, what is A plus B? When you add kx plus omega t plus this, what will that be? Well, that will be 2kx minus 2 omega t plus delta over 2. Alright, I'm going to write down that for you. So this will be 2a cos. I showed you that A minus B will be negative delta. And you should also know that cos of negative delta is the same as cos of delta. You know why? Because cos is positive in the fourth quadrant. So you get, this is actually cos of negative delta over 2, which is the same as cos of delta over 2. And when you add this quantity to this and divide by 2, you get this, kx minus omega t plus delta over 2. So this is the general form when two waves meet at a point with a phase difference of delta. Alright, now why have I colored this quantity? If you look at this, 2a cos delta by 2, here is a constant, where delta is the phase difference. Therefore, this is the amplitude of the resultant wave. The amplitude of the resultant wave is this quantity, 2a cos delta by 2. That is what I want you to take note. Alright? Now, the amplitude of the resultant wave is this, 2a cos delta by 2. When delta equal to 0, look at that. When delta equal to 0, what is cos of 0? Cos of 0 is 1. So when delta equal to 0, the two waves are in phase, then the resultant amplitude will be 2a. Cos of 0 is 1. When delta equal to pi, what is cos of pi by 2? Cos of pi by 2 is 0. Therefore, when delta equal to pi, the resultant amplitude will be 2a times 0, because cos pi by 2 is 0. That will be 0. Alright. Here I have the illustration of a wave pulse advancing from the left, another wave pulse advancing to the right, interfering at the center. Can you see that? When the wave pulse meets at the center in phase, you create a bigger wave, and they pass against each other, they interfere, and you can see the amplitude changes as we go from left to right. Each time you have the resultant amplitude. So a wave advancing from the right and a wave advancing from the left interfere, producing a larger wave at the center. Let's now do a couple of problems. Two waves having the same frequency, wavelength and amplitude are traveling in the same direction. If they differ in phase by pi by 2, and each has an amplitude of 0.05 meter, what is the amplitude of the resultant wave? Well, they differ in phase by pi/2. What that means is, if one disturbance causes a particle to be on the crest, the other disturbance wants the particle to be at the equilibrium position. That is a phase difference of pi/2. Now, do you remember the equation we developed for the resultant amplitude when two waves meet? Well, those equations are important. We used the trigonometry result and we said why the resultant amplitude is equal to what? 2a cos delta by 2. 2a cos delta by 2 is the amplitude. Then sine of kx minus omega t plus delta by 2. And that's a relation that we obtained. The equation of the resultant wave is given by y equal to 2a cos delta by 2 sine kx minus omega t plus delta by 2. And the amplitude of the resultant wave is this, 2a cos delta by 2. The amplitude of the resultant wave is 2a cos delta by 2. Now, the amplitude of each wave A is 0.05 meter, and delta, the phase difference between the two waves, is pi/2. Therefore, when delta equal to pi/2, what is delta by 2? Divide pi/2 by 2, you get pi/4. Therefore, what is the resultant amplitude? Is 2a cos pi/4. And that will be 2a, 2 times 0.05. Anybody tell me what is the value of cos pi/4? Don't you know that? Cos pi/4 is square root 2 over 2. 0.707, I think. That will be 2 times a 0.05 times cos of pi/4 is square root 2 over 2. And that gives you 0.071 meter is the resultant amplitude due to the superposition of the two waves. Okay, let's do one more problem. Two transverse waves of frequency 40 Hz propagates down a string. 2 points on the string 5 centimeters apart are out of phase by pi/6. If this is the string, 2 points on that string that are 5 centimeters apart have a phase difference of pi/6. What does that mean? It means a particle here has gone all the way up to the upper extreme. The particle here has just received the energy and begins to vibrate. That's the meaning. The phase difference is pi/6. What is the wavelength of the wave? At a given point, what is the phase difference between two displacements for times 5 milliseconds apart? What is the wave velocity? Alright, let's start part A. What is the wavelength of the wave? Now, wavelength is the distance between two nearest particles that are in the same phase of vibration, isn't it? Yes. Now, a phase difference of 2 pi, you know that if the phase difference is 0, it is the same as a phase difference of 2 pi. For example, when one particle completes one vibration, a second particle begins to vibrate. They are in the same phase of vibration. You can say the phase difference is 2 pi. So a phase difference of 2 pi between two particles means that they are in the same phase of vibration. So we are looking for wavelength. Means what is the distance between two particles that have a phase difference of 2 2 pi. That's what we're looking for. Now here, a length of 5 centimeter corresponds to a phase difference of pi by 6. You can see this is a very simple problem that we use for normal shopping. Now, a phase difference of pi by 6 corresponds to a distance of 5 centimeter. What are we looking for? We are looking for the distance between two particles that differ in phase by 2 pi. If a phase difference of pi by 6 corresponds to a distance of 5 centimeter, a phase difference of 2 pi will correspond to what distance? That is what we are after. Now, what all you need to find out is how many pi by 6s are there in 2 pi. Can you tell me that? How many pi by 6s are there in 2 pi? There are 12 of them. Pi by 6 multiplied by 12 is 2 pi. That means to find the distance corresponding to a phase difference of 2 pi, what all you need to do is multiply the 5 centimeter by 12. That will be 60 centimeter, and that will be the wavelength. Here, a length of 5 centimeter corresponds to a phase difference of pi by 6. Then you got a distance of 5 centimeter. The phase difference between these two particles is pi by 6. So delta is pi by 6. What length will correspond to a phase difference of 2 pi? That's our question. 2 pi is 12 times pi by 6. There are 12 pi by 6s in 2 pi. Therefore, the corresponding distance will be 12 times 5 centimeter, which is 60 centimeter, or 0.6 meter. 0.6 meter is the distance between two particles that are in the same phase of vibration or having a phase difference of 2 pi. That means the wavelength is 0.6 meter. I hope you understood or followed the argument I am using. Now, in B part, at a given point, what is the phase difference between two displacements for times 5 milliseconds apart? Now, what is the information we know? We know that the frequency is 40 Hertz. In 1 second, the particle vibrates 40 times a second. That is the meaning the frequency is 40 Hertz. Therefore, what is the period of the wave? The period is 1 over 40 of a second, 0.025 second, which is 25 milliseconds. And you know that during the time the particle completes one vibration, the distance traveled by the wave is a wavelength. Now tell me, what is the distance traveled by this wave in 25 milliseconds? Is 0.6 meter, the wavelength. So this means that the phase difference between two displacements, so the phase difference between two displacements a wavelength apart is 2 pi. So a time of 25 milliseconds correspond to a phase difference of 2 pi. Therefore, the question is, a time of 5 milliseconds will correspond to how much phase difference? That's the question we want to answer. To cause a phase difference of 2 pi, the wave pulse travels for 25 milliseconds. Therefore, when the wave pulse travels for 5 milliseconds, the phase difference is 2 pi divided by 5, 1/5 of that 2 pi. Alright, what is the wave velocity? Wave velocity V equal to F lambda. Frequency is given to be 40 Hertz, and lambda, the wavelength, we just calculated as 0.6 meter, and therefore wave speed is V equal to 40 Hertz times 0.6 meters.